All right. So what I think students struggle with the most within mathematics is reading, comprehending, interpreting, notation, and the different visual or graphical ways that we represent information. Okay. If we can understand the way that we're allowed to graph things, the way that we're allowed to manipulate X and Y axes and how they're developed, it makes the work and the use of the algebra and the interpretation of the algebra a lot easier. Okay, so yesterday we were talking about this thing here, and at the end of the period we kind of quickly, haphazardly created this graph, okay, and then the bell rang, we didn't have a whole lot of time to talk about it, okay. So we looked at those ordered pairs, and then that column that goes 0 to 300, 10 to 372.5, all the way down to 40, 590. We've got that graph, okay? So this is the second to last page, I believe. The number one thing I want to talk about is the fact that you are going to collect data points like we did over here, okay? We're going to call these ordered pairs data points. We collect those, and we want to graph them, okay? So if I'm graphing this thing on my own and the graph has not been developed by some other author, do I want to sit here, because I got to go up to 590. Do I want to do this 1, 2, 3, all the way up to 590? No. I don't even want to do that for the x-axis that goes from 0 to 40. Okay? That's going to be very time-consuming, tedious, pain in the butt. You don't want to do it. Okay? So what we can do, though, is we can shorten our graph by, instead of skipping by 1, maybe we skip by, what did I skip by here, from 300 to 350, 350 to 40, 400, 400 to 450? Skip by 50s, right? Okay. On my x-axis, I don't have to skip by the same thing. Does it make sense? A lot of times, so the previous examples, my x-axis was going 1, 2, 3, 4, 5. My y-axis was going 1, 2, 3, 4, 5. So the intervals were the same, but they don't have to be. Okay. On my x-axis, my intervals are a length of 10 units. Okay. So 10 to 20, 20 to 30, 30 to 40. Y-axis is going from 300 to 350, 350 to 400, so by 50s. Okay. You can change those to anything that you want. Okay. So my graph represents that data, but if you're a person that says, well, I'm going to go by 5s on the x-axis. So you go 5, 10, 15, 20, 25, 30, whatever. Maybe you're a person that says, I want to go by 2s. Okay? As long as you are consistent, your graph might look a little bit different than mine. It talks about like the scale of your graph. I'll look at my screen right now. You guys know what aspect ratio is? Like does my graph, so when I do this, well, my new computer doesn't do it. But you guys have watched like movies on TV or like a Blu-ray, and if you got widescreen TV, sometimes the top has like a black line through it, and the bottom has a black. You know what I'm talking about? And then the video's in between. You're like, well, I won't use the whole screen, but it's just a widescreen display because you're set for like a 4:3 ratio, but the DVD is written in 16:9, okay, or 9:16. What happens there is things are stretched out, things are distorted, but it's still the same movie, isn't it? Okay? So you might stretch out your x-axis further than me, you might compress it more than mine is or whatever, and it might distort your picture compared to mine, but it's still going to be the same information. Does that make sense? Kind of the same movie if we go along those lines, okay? Or make that comparison. What I really want to talk about here is this idea here. How many values are being represented right there in that yellow on that y-axis? 300, right? How many are being represented right there? 50. How many right there? Another 50, right? There, 50, 50, 50, right? My initial interval that is yellow there, that has that kind of squiggle on it in the y-axis, is different than the others. If you're going to go that route, that's fine, okay? But you have to indicate with this little squiggle here, okay? We would call it kind of a broken axis, that notation in my graph is telling everybody make sure you pay attention because that interval is greater than what that interval is, even though that's the same size. Does that make sense? Okay. It's just something to pay attention to. If you don't do that, that's fine. If you still want to go by 50s, okay, so you could, take your graph over here, and if you want to still go by 50, 100, 150, 200, 250, 300, and there's your first point then, and then continue up to 350, 400, all the way up to that 590, that's fine. But what do I find out? Didn't I waste? Cursor died. Come on. If I do all this before I get to my first point to plot, didn't I really waste a lot of room right there? So what they're saying is cut all that out and condense it down to like that right there and just start at 300, okay? So that's kind of what's going on there. We're saying we're cutting that portion of the x-axis or the y-axis out because we're not using anything on that, and we're going to bring it, compress it all down. So what you're going to see from time to time is things like that little squiggle I showed you in your graph, and sometimes it might even look like this. It might be they come down the y-axis and they put two like slanted lines there, and then they keep going down with the y-axis, okay? So those are the kind of variations of what you're going to see for a graph. Why do I show that? Are you going to use that very often? Probably not on your own. But we get to the inter-course exam, we get to the ACT, something like that. They might display a picture that has that in there, and if you've never talked about it, you know what it means, okay? So I want to make sure we understand that. And that's a science thing that happens a lot, especially in science. So you get the inter-course exams on science, you get the ACT on science, you get the ACT in math, inter-course exam in math. Those things are potentials in showing up. Does that make sense? Okay. But if they don't tell you, you have freedom in regards to what you choose to skip intervals in your y-axis and your x-axis. So you want to go by 100, you go by 100. Okay. You want to go by 25, you go by 25. You want to go by 7, go by 7. Doesn't matter. Okay. We cool with that? All right. There are two types of graphs that we tend to talk about in algebra. Okay. You guys ever heard of scatter plot before? Okay. Scatter plot is just when you start plotting the data points, right? And then once you plot them all, you don't do anything else. Okay. Now, generally speaking, with scatter plots, you've collected data somehow, and a lot of times they're like maybe not linear. Okay. They might have kind of a linear correlation, but they could be bouncing all over the place, okay? The graph I've shown here is these are a linear relationship, right? Okay. But scatter plots or just any graph in which I do not connect the dots, okay? I do not connect the points. We call those discrete graphs, okay? Discrete just means composed of isolated points, no connecting or anything like that, okay? If I do end up connecting them, in that bottom picture, we get what we call continuous graphs. Okay, this is something that I think is interesting in the way we do mathematics. We need to have the ability to talk about things that are continuous in Algebra 1, Algebra 2, Algebra 3, or free calc, trigonometry, all that kind of stuff. But it's not until we get to calculus that we can actually mathematically define what it means to be continuous. Okay, so continuous graphs kind of look like that. What most people will argue in Algebra 1, Algebra 2 type thing, to determine if something's continuous, if you can put your finger on the furthest left part of that graph and trace the whole graph without lifting your finger, then it's going to be continuous. Does that make sense? If you ever have to lift your finger, then it's not continuous. So I'll show you a graph here that would not be continuous. We go, let's see here. Let's say if we go from -2 to x to 0 graph x squared. If x is greater than 3, let's graph 2x. If I graph that orange graph right there, would you agree that I can put my finger right there where my cursor is and start tracing that thing? Okay. But now when I get to that spot right there and I want to go trace the rest of the thing that is orange, my cursor comes off and it's not the finger anymore, right? So that's kind of my hand coming off the board, and now I have to start tracing there, right? So when my cursor is that crosshair, that's the idea that I had to lift my finger off the page to continue graphing. Does that make sense? So that graph, because it's got a gap in it, is said to be not continuous, and the mathematical word we use for that is discontinuous. D-I-S is the prefix we say, discontinuous. All lines are continuous, okay? And really everything that we graph here early on will be a continuous graph, okay? There's some terminology that you might see in your homework, you might see on the end of course exam. I want to make sure we're exposed to that. The next two things, so we'll get through these next two graphs and then give you some time to work on an assignment. But I want to jump to the last one first. We're going to do the x squared minus 1 first. And then we'll go back to that one that has absolute value. Before we do this, I'm just going to, you don't have to scroll through your previous information, but let's look at the first graph that we did, okay? The first graph that we did, we talked about that exponent right there, okay? Because right now there is nothing written there, right? Would you guys agree that there's nothing being written right there as an exponent for the x? Then it's an understood 1. Does that make sense? It's like if I just say I have y equals x, what's the coefficient right here? 1. We don't usually write it though, right? Okay? But it's an understood 1. The same thing applies to the exponent. Okay? If it's not written, it's a 1. Okay? So this is x to the first power. If I had x to the first power in my equation, what was the graph? What kind of image do we get here? That's a line, right? So this negative 2x plus 1 was linear, because it created a line. What about this one? What is the exponent for this x right here? The exponent. The coefficient's negative 1/2. The exponent right here is a 1, right? What kind of graph did you get? You got a line. So, linear. X to the first gave me a line 2 times, right? What about down here? What's the exponent here for this x? 1, right? What kind of graph did you get? A line. Linear. Okay. What was the exponent here? It's an exponent of 1, right? What was the graph? We connect those? Linear, right? Come down to this next one, the one we're going to do. What's the exponent? 2. Okay, now based off of the pattern that we just kind of investigated, do you think this is going to be linear? No. Okay? Whenever you look at your variable and it has an exponent, the largest, so eventually we'll have multiple x's up there. Okay? We might have x squared and x to the first, we might have x to the third, x squared, x to the first, but that'll be towards the end of the year. But so right now there's going to be x up there 1 time. Okay? If it has a power of 1, it's going to be a linear relationship. You're going to get a line. If it's power of 2, it's not linear. Does that make sense? And that's going to be a non-linear type of graph. Is that all right with everybody? Okay. And there are a couple other, the absolute value one is going to be one that we also talk about in regards to whether it's linear or non-linear as well. But right now, because of that power 2, the powers are something that they're an identifier that tells you automatically whether the graph is going to be a line or not. Okay? If it's a power of 1, it's going to be a line. Power different than 1, not a line. Is that all right? When it's not aligned, here's the thing. I told you when it's aligned, it didn't matter what x's you chose, right? Okay? When it's nonlinear, the x's you choose are important, okay? And the idea is that you might not know what x's to choose. My suggestion is that when the power is different than 1, you choose values that are negative and values that are positive, okay? Choose on both sides of the x-axis because it's going to give you a good idea of what that complete graph looks like. What happens is this class, Algebra 1, is mainly concerned about dealing with things that are linear, understanding lines and all the different things we can do with them. At the end of this course, we start talking about things that are like this, okay? Where they're called quadratic equations, but they're not it's one specific type of nonlinear equation, okay? And we learn that for the end of this year, and then you make your way into Algebra 2 and start learning that at the beginning of Algebra 2. And at the end of Algebra 2, you start dealing with, well, x to the third and x to the fourth type things. And that gets you into Algebra 3 or pre-calculus, and you start investigating that stuff a little bit further. Does that kind of make sense? Okay? So it's the same type of information, just with different graphs. That, though, that's the identifier, okay, to tell us whether we have something that's linear or nonlinear, okay? So I'm going to choose values that are on both sides of x, or both sides of the x-axis. So I'm going to start with -3. We'll go -2, -1, 0, 1, 2, and then hopefully maybe we'll start to see a pattern here. Okay, so I'm going to go all the way down to 3. So we'll do those 7 independent variables, but it shouldn't take all that long to evaluate all 7 of those. When we do this, okay, so here's the idea. I'm replacing x with -3, right? This wasn't a huge issue when it was x to the first. But right now, this entire thing that is blue is getting raised to the second power, right? Okay? So I'm replacing that entire thing that's blue with -3. So -3, that whole thing is going to be replaced in that position of what x is. Does it make sense? Or where x is. Is that okay with everybody? So when I put this power of 2 up there, is it just the 3 that gets squared, or is it the -3 that gets squared? The -3. So here's my argument to you. When you substitute, and this is just something you want to get used to doing, whenever you're going to substitute a variable in for something, make sure that when you do that substitution, put it in parentheses. Okay? So the idea, so I highlighted here to kind of prove my point, but if I had parentheses there around x, I should have parentheses there. Does that kind of make sense? Because I want to make sure that the -3 like this squared is +9, right? What is this squared as? What does that give me? -9. We want to make sure we get the right one, right? Okay? So we're going to get -3 squared minus 1. That's what y is equal to. So what's that giving? What's -3 squared? 9. Minus 1 then is 8. So I get the ordered pair, -3, 8, right? Okay. Let's plug -2 in. Y equals, so -2 in parentheses, squared minus 1. What's -2 squared? 4 minus 1, 3. So we get -2, comma 3. Put -1 in. What's -1 squared? 1 minus 1 is 0. So -1, comma 0. 0 is always a good one to put in. So what's 0 squared? 0 minus 1 is -1. So 0, -1. Plug 1 in. What's 1 squared? 1 minus 1, 0. So I go 1, comma 0. Y equals, plug 2 in. What's 2 squared? 4 minus 1, 3. Now, what you're going to start seeing here, now understand it's because, and this pattern is going to exist because there's a pattern here, right? Were these all +1s? Right? What we've been doing in the past, looking at that pattern. So there's a pattern existing here. What's going on with your y? went 8, 3, 0, negative 1, and then got back to 0, and it went back to 3, right? Well, think about this. Right now, if I look at this position as my starting point, and I go that way looking at my y's, do they go 0, 3, 8? Make sense? Those y's go 0, 3, 8? Going that way, do your y's go 0, 3? What do you think the next one's going to be? You see the pattern? 0, 3, 8, 0, 3, back to 8. If you actually evaluate here, what's 3 squared? 9 minus 1 is 8. So when I add 3, it goes with 8. So there's a pattern there that's happening with your y. Okay? Now, it's not a linear pattern. Okay? We call it a quadratic pattern. But let's look at graphing these and see what happens. If I graph those, so negative 3, 8 would be, is everybody okay with me kind of quickly graphing stuff? And at least the ordered pairs? Okay. So left 3, up 8. I'm going to go left 2, up 3. Left 1, up 0. Okay. The next one is 0, negative 1, so I don't move anywhere left or right, but then I go down 1. And then I go 1, 0, so right 1. And I had 2, 3. And the last one then was 3, 8, right? When I look at that, does it look like a line? No. Okay. Huh? Okay. That's a good. Okay. So you're saying that portion right there, if I reflect across the y-axis, makes that part, right? So what you're seeing then is exactly what you said, and it's because of what we saw here with that 0, 3, 8 and that 0, 3, 8, is that there is symmetry there, right? Okay, is that the word you're looking for? Reflection, symmetry, that's gonna, your body is symmetric, right? Down your nose, okay, middle of your body. Left-hand side, same as the right-hand side. But this shape is called, anybody know what that shape's called? No. Anybody heard the word parabola before? Yeah. Okay. That is a parabola, okay? If you ever look at a flashlight, okay, don't turn it on and look at it, but just look at so look down at the lens of the flashlight, you've got a light bulb in it, right? Okay. Let me see if I can give you a picture of this. All right. I think this will work. Well, this stinks. There we go. All right. All right, so right now I'm going to take this shape right here, okay? Now, just the way we're looking at it and the color that I've got here, let's change the color to, okay, yes. Let's change that color to that. Let's see what this looks like. What happened? Where'd it go? I don't know what happened there. Hold on a second. Let me. Okay, there we go. So I want to change this color. That's my axis color. That color to that. Will that work? Can you kind of, so guys, can you see that that's kind of it's called a parabolic lens, okay? But I took that parabola that we just created and I just rotated it 300 degrees around its axis, okay? If you were to look down, so you see this, that green arrow right there, okay? So if that was a flashlight, okay, that would be the bulb in a flashlight. Does that make sense? Okay? If you look down at the lens of the flashlight like this, okay, the like silver chrome kind of covering on the inside of the flashlight is going to be that lens that I just created that's in black there. Does that make sense? And the reason that is because this light bulb is going to send off light, right? Light waves. And those waves will be emanated 360 degrees, okay, in all directions in space, and some of those rays will bounce off of the parabola, right? Does that make sense? Okay? And when they bounce off the parabola, what happens is that they all go in one direction. They will all, so the light will come from where this green thing is right here, that light. It'll come down and bounce off the inside of that lens on that chrome surface, and then it will get redirected in the same direction as that green arrow. So it'll go straight out of that cone. Does that make sense? Okay, and that will create a beam of light. Does that make sense? Your headlights are this way on your car. Okay, anything that produces a beam of light has a parabolic lens like this. You said a satellite, right? Satellites are this way because what happens is that we send radio signals, TV signals, all that kind of stuff through space. They're hitting us right now. Okay, they're touching us right now. You can't feel them. But what they do is they come through space and they hit this shield. Okay, that is your satellite dish, and it then redirects and bounces right to there. And right there on the set, you've seen satellite dishes, they have like an arm coming out the middle of them, right? That arm has either got a microphone on it or some type of transmitter to take that radio signal and turn it into what you see then on your TV or whatever. Does that make sense? Okay, so parabolas are something that we use a lot in everyday life. Okay, so what we do is we try to investigate them a lot in high school math, so that we understand then the technology that hopefully uses them later on. Okay, if you take my other classes that I offer later on in high school, we talk about that stuff and we actually start kind of investigating the science aspect of those shapes in a little bit more detail. But that's a parabola. Okay, here's why I told you at the beginning that it's important on what kind of x values we choose. Okay? If I would have just chosen these x values right here, 0, 1, 2, 3, that would mean that I didn't have that stuff show up. Does that make sense? If I don't have that stuff show up, does that mean I don't, does it show that I don't have the entire graph? Does that make sense? Okay. So when we start graphing things that are nonlinear, it is important to choose a variety of x values. Some that are negative, some that are positive, and probably makes sense to always choose 0. Does that make sense? Okay. If it's linear, then you have a lot more freedom on what your x's that you choose are. Okay. Let's come back up to this one then. Okay. So this one's a little bit different because the exponent is a 1 there. If I look at that x inside those bars, what are those bars?
Absolute value bars.
Absolute value. Okay. The exponent that is here is still a 1. Okay, but the absolute value is going to do something to our variables that we choose that is unique to this type of function. Okay, so again, this is one where we want to choose some values that are negative, some that are positive, and also choose 0. Okay, so I'm going to choose negative 2 will be 1. I want to choose a little bit further. Let's go negative 5 as well. Negative 5, negative 2. Let's choose 0. Let's try 3 and 4. Just getting a variety of negatives and a variety of positives, right? Okay. Now, because my x's there that I chose don't have a particular pattern, they go +3, +2, +3, +1, right? No particular pattern, so I'm probably not going to be able to recognize a particular pattern in my y's. So here we're going to have to evaluate all of these, but it shouldn't be all that of a tedious task. If I choose negative 5, okay, remember what absolute value does. Absolute value, when we're evaluating, is a grouping symbol. It tells you basically what your parentheses tell you in PEMDAS. You have to do that first. So what's the absolute value of negative 5? 5. And then you're going to remove 4 from that, so you get a result of 1. Good. So I've got negative 5, comma 1 as that ordered pair. Let's do the same thing for negative 2. Absolute value of negative 2. 2 minus 4, negative 2. My hope is that we realize when we do these, if you can do the order of operations the first time on your first independent variable, is it the same set of ordered operations for the next ones? Did I do absolute value in both those first? And then subtracted 4 from both those? Okay. So the steps are the same. Once you evaluate one of them, the steps are the same as you evaluate for the other x values. What's the absolute value of 0? 0 minus 4 is negative 4. So 0, negative 4. Y equals, okay, let's go absolute value of 3. What's absolute value of 3? 3. Make sure it doesn't change the sign. It just makes it always positive, right? So it doesn't make it as opposite. It always keeps it positive. So absolute value of 3 is 3. Minus 4 is negative 1. So I've got 3, negative 1. And now what's absolute value of 4? 4 minus 4, 0. So I've got 4, comma 0. So now let's plot those points. Okay. Negative 5, 1. So maybe right there. Negative 2, negative 2. Right there. 0, negative 4 right there, right? So now I graph 3 points. Do those 3 points look like they fall in a line? Yeah. And they do. Okay? But I'm not going to connect that line yet. Okay? Because now when I go 3, negative 1, 3, negative 1, that one there, and I go 4, 0, that one there, do those green points, do they look like they fall in a line?
Yeah.
Yeah, they do. Okay? Now here's the thing though. To the left of the y-axis, we have a line. To the right of the y-axis, we have a different line. Okay? If I connect these, they go that direction, and then they're going to get there, and they're going to go to that direction. Does that make sense? Okay? Every one of your absolute value problems, graphs, right now, are going to look like that. Okay? We'll talk later, okay, that this graph here, so this will be I don't know, 3 or 4 months from now, if we graph x minus 4, ignore the absolute value, it's going to be this line right here, okay, going on forever, even past this -4 coming down here in this quadrant, okay? But once I put those absolute values on it, it takes this portion down here and flips it and makes it become this portion there. So we'll investigate how to do that later on. But right now, I want you to know that your absolute value is going to look different than your linear functions. It's going to look different than your powers of 2. Does that make sense? Okay. But we still refer to that one as nonlinear. Does that make sense? Because nonlinear, okay, lines, a geometric concept about lines is that lines do not have any bends in them. They're straight. They don't bend. There's no holes. There's no gaps. There's no corners or anything like that. They're straight forever. Okay? This is not straight forever, right? There's a bend or a corner down there at -4 or 0, -4. So it's nonlinear. Does that make sense? So what I need you guys to know, so I'm going to give you an assignment here. And before you even graph any of them, you should know automatically which ones are lines and which ones are non-lines. Okay? If I can find the handout. The homework assignment that was 4 that I had shut off last night. Okay? I have reopened that. I've given you I believe it's going to shut off tomorrow night. I put 2 more similar exercises on there in case you want to go back and fix anything if you did finish it. Yes.
Wasn't 4 assigned 2 days ago?
Yeah. But there might have been some questions on there that are now maybe easier to answer correctly once we've now finished the notes completely. Okay. So you have the opportunity to go back and fix some of those if you want to. This handout here, okay, so as I go through this, the front page, okay, that first one, what's the exponent on that first one? That's a 1, right? -2x to the first power. So what kind of graph is that going to be? Linear. Go to the next one, 1/3 x plus 2, what's the exponent? That's 1, so what's that going to be? Linear, okay? Go to the back. So it's the exponent that goes with that x, be that superscript number. So it's a 1 right there, right? So the first 3 are linear, yes. If I go to the back though, look at the first one. What's that? Linear. It's that -x plus 1. That's a first power. What's that one in the middle? Non-linear, but it's x squared, right? So is it going to look like that one we had in our notes? Yeah. Okay, now it's going to be positioned in a different spot on the x and y axis, but it's still going to be a parabola when you're done. Okay? The last one I forgot to write. Okay? So the last one, I want you guys to graph. So write y equals absolute value of x plus 2. Okay? So, is that going to be linear?
Yes.
What is it? No, it's absolute value, right? So absolute value, that's going to be that V shape.
Oh.
Okay? And that V shape, what we refer to that as nonlinear. But that's going to look, the last one was absolute value of x minus 4. This one's going to look very similar. It's just going to be positioned in a different spot on your x and y axis. Okay? What we're going to find out is we're going to learn how to graph these by creating these tables. And we'll spend a couple days on this. But as we move through the rest of algebra and into algebra 2 and basically algebra 3, you start to learn shortcuts for how to graph these things. So in about 2, 3, 4 weeks from now, we'll stop making these tables because going through these tables and graphing lines with these tables is time consuming. There are other patterns that we can use to help us graph them a lot quicker. Does that make sense? So that's the plan. That's what we're going to get into. Give you, obviously, you got about 6-7 minutes here. You guys can work on that and you ask me questions. That is due tomorrow. What I'm going to do with that, guys, is, because I'm not going to grade what your X's are and your Y's. What I do is I will complete that worksheet and I will graph them and then I'll go scan those on transparency and I'll take that clear transparency and I'll lay it on top of your homework. And if the lines match up, did you do it right?
No.
Yeah. If the lines don't match up, then I go back and look and see, okay, where did you make your mistakes, that kind of stuff. So I will grade that. We'll collect that. On the ones, obviously, that you choose X's, make sure that you choose X's that are intelligent, okay? We kind of talked about that yesterday. So give that a go. I'll collect that tomorrow.